In this section, we're going to be using Python to make a sample image for cell counting in FIJI. What we're going to be doing is making an image that has circles of random size and position, but a known number of circles. So in this case, we're going to be making 20 circles that will have random size, random position, but a known distribution as well of those sizes, so that we can then further on check to see if we're detecting sizes, detecting position, and measuring these distributions correctly. So the first thing we're going to be doing is importing the packages that we need to run this script. So we're going to be running matplotlib inline so that we can see images, or figures rather, in the Jupyter notebook. We're going to be importing math, importing numpy, which you've gone over in the prerequisites, and importing matplotlib, and importing random so that we can have a random distribution of sizes. So just hit Control-Enter, import that. And first thing I want to just go over really quickly is how we find the length of a list of numbers. So if I make a sample list, 1, 2, 3, 4, 5, I can call len for length on sample list, and we get a output of 5, so the length is 5. That will just come up later on, and it's a useful thing to keep in the back of your mind. That's just how we call length, and I had nowhere else to put it in this course. So first thing we're going to be doing is generating an image matrix of zeros that we're going to plot objects into. So we want just a black canvas, if you will, a blank image that we can then paint our objects onto. So an image in its rawest form in Python or MATLAB or any programming thing, it would just be a matrix. So if you have a 512 by 512 image, then it's 512 rows by 512 columns. If you have a 1024 by 1024, it's 1024 rows by 1024 columns. And so each entry in that row column is 1 pixel. If we have an RGB image, then we have a multi-dimensional array, a multi-dimensional matrix. So if you have a 512 by 512 by 3 for red, green, and blue, that's a 3-dimensional or 3-layered 512 by 512 array. We're going to be making a 1024 by 1024 3-dimensional array. The first 1024 by 1024 matrix will be red, then green, and then blue. So we set img, that's just the default for image, np.zeros. So we're just making a numpy array of nothing but zeros, 1024 by 1024 by 3, data type. Cannot type today. And now that just initializes a blank canvas of an array. It's just going to be all zeros, 1024 by 1024 by 3. Next thing we're going to be doing is importing from Sci-kit image circle, which is just a function that makes circles. Easy enough. There's other functions that make squares, ellipses, triangles, etc. We're going to use circle because all we need for circle is a center and a radius. So the function circle requires actually 4 variables: row, column, radius, and image shape. The row and the column give the center of where we want our circle to be. So if I write row, row, column, column equals circle 800 by 156 by 25, and then image.shape. Then let's just see if I print length rr, print length cc, and then image. Oh. Actually, let me show you what that is first. So here what we're doing, we've got row, row, column, column, circle, 800, 156, 25. So that's the center of our circle is going to be in row 800, which would be the y value. So if you imagine the rows like an Excel spreadsheet, the row is row 800, the column 156, so it's going to be fairly far down the image and a bit in, 800 by 156. It's going to have a radius of 25, and then the image shape is just passed in there so that the function knows what the matrix size is that we're dealing with. And you can see then the size of my object is there's 1941 rows and 1941 columns that are in this circle. So that would be every pixel. There's 1,941 pixels that will be covered by this circle. So then, how do I set that? Just call image. So now what I've said is that image RRCC and then this comma, semicolon. The semicolon is then putting it across all three layers, the red, the green, and the blue. So that's just saying every row and every column that's denoted by the circle, every row and column that's been found by the circle function that we want to fill in, we're now going to set to 1, 1, 1, which is just full value red, full value green, full value blue, which if you mix all three colors together gives us white. So again, that's going to be 1,941 pixels. Now, what's this image.shape that we passed in there? Well, I can see that it's just that. It's 1024 by 1024 by 3. So I can just write some simple code and pull that in. And there's 1,024 rows, 1,024 columns, and 3 colors. So now that we've put a circle into our matrix, we probably want to look at this matrix, see what it actually looks like, look at it as a figure. So we call fig ax1 equals subplots. Now the reason I'm using subplots is it's just a nice syntax to get used to writing, so that when we want to call more than one figure at a time, we can say maybe use columns. We can have more than one column or more than one row. So if we did a 2 by 2 and cols equals 2 and rows equals 2, we'd have 4 figures that we could put into, or 4 subfigures we could put in there. And we're just going to make our fig size equals 10 by 6. All right. So then we want to do is show axes 1 imshow dot image. So we're just going to be on AX1, we're going to be calling imshow dot image. Then we want to just set the title. So that's easy enough. Set title circles. And then we can say we want the axes on, which will show us the axes so that we can see that we have that it starts in the upper left hand corner, that 0, 0 is in the upper left hand corner, as opposed to most graphs that we think about where they start on the lower left hand corner, and then we can just show it. And that would work. I apparently typed plot someplace. There we go. And now we see that we've got our circle at 800 by 156. And we can see that, yes, the first entry here, let's see, 800 by 156, it goes yx as opposed to what we're normally used to, which would be xy when we're plotting. So it's yx. Now, what I'd like you guys to do in the next few minutes is go back and change the position of the circle and replot the image. So maybe make this 400 or make this 356, hit Control Enter, run through these things again, replot it, and see what happens. So if you came through and you tried the exercise I had just given, what you might have seen is that you have 2 circles or 3 circles in your figure now. Now, why is that? Well, let me go up here and I'll change this 800 to a 400, run it again, and run this section of code again. And I've got 2 circles. Now, why is that? Well, I went up here and I changed the center of my circle. So I called new row and column for circle, so that I've got, or rather declared new rows and columns in circle. So now that these pixels that are given by these rows and these columns will now also be filled. But I didn't clear the first section out. So the first circle is still there. So now my array has 2 circles filled into it. So if I want to just have 1 circle, I have to reinitialize my array. So I can go up here, make np.zeros, make a new blank array. You'd see that if I just drew that now, I'd have a blank array. So now I can rerun this section of code, come back down here, and I'll just have 1 circle. Now if I make this again, maybe make it a 900, run this, I have 2. If I run this section of code to make another blank image, run this section of code, now I just have 1 circle again. All right, now what we'd like to do is generate some circles with random Gaussian distributed sizes and random distributed locations. So we're going to use the random.gauss function to make our random Gaussian distributed radii first. So we imported the random library early on, and now we're going to call the random.gauss function on it. Before we do that, I'd like to just reinitialize our image so that we just have a blank canvas to start with again. And first thing I'm going to do is call random.seed. I'm going to use a seed of 48. Random.seed just sets a pseudo-random seed number that we can use so that everybody has the same randomly generated, random in air quotes, randomly generated radii and centers later on. After that, what we need for Gaussian distribution is first an average center. So that's going to be 15, and I'm going to set a standard deviation of 4, and I'm just going to initialize a list so that we can append into it our radii. And now what I want to do is just make a for loop to generate a list of radii. So for loop for n in range 20, make 20 circles, radii dot append, we're just adding to the list, random.gauss, and it just calls for 2 arguments, mu and standard deviation. And if I'd like to see what those look like, I can view the first 10 of them. So view the first 10 entries of the list by just calling radii 0, 2. All right. Now what I'd like you to do in your practical right now is just show how you index a single entry, find what the 11th radii in the list, and how do we slice a list, just to practice these things a little bit, find the 11th through the last entries of the list, and in the next segment we'll just quickly go through how that would be done. All right, as we come back from our practical, let's go over really quickly the answers. So in the first one, how do we index a single entry? Well, we just call a single location or single index. And how do we do the 11th radii on the list? Well, we just call 10. Why is that? Because Python starts at 0, and so the first entry in any list is 0, so the 11th entry would be 10. How do we slice a list? Well, we use the same syntax, radii. We start at 10 because it's the 11th entry, and all we do is put the semicolon to go through and get to the end. Now what we need to do is define the center positions for our 20 circles. So first thing I want to do is just create an empty list, centers, that we can append our center positions for each one of our circles into. Now what I want to know is, what is the dimensions of my image that we're going to put the circles into? We're just going to call row, columns, and colors on image shape again. So this will just give us the dimensions of our image that we're working with. We're going to need that in just a second, and I'll show you how. But first, let's just think about what we're going to be doing. We're going to be making 20 centers. So we're just going to make a quick for loop, for k in range 20. And in that, I need to define my center somehow. And I'm going to use a function called random.randRange. RandRange takes 2 arguments, min and max, and it returns a number between the min and the max, randomly. So if you have between 0 and 10, then it'll give you an integer between 0 and 10. So we're going to need two of these, one for our row position and one for our column position. Now, in each one of these, I need to put our min and our max. So for our min, we could use 0, and for our max, we could use 1024. But if our images are no longer these dimensions, then what we'll have is that we'll have an unspecified number, because if our image only goes up to 512 and we try to draw a circle at 900, that won't work. So we want to just go from 0 to rows and 0 to columns. But that still might not work, because if we have a radius of 15 and we have a circle, say at 0, 0, then most of our circle will be off of the image, and a lot of our image detection algorithms in FIJI won't detect, our cell detection algorithms in FIJI won't detect a cell that's halfway off of the image. So how do we get around that? Well, instead of a minimum of 0, we could use a minimum of our average radii. But we know that we have a standard deviation around that radii, so I'm just going to say 2 times mu, so 2 times our average radii. And instead of being rows, I'll use rows minus 2 times mu. And similarly for columns, for our column values, I'll do the same, 2 times mu, and then it'll be columns minus 2 times mu. So it'll give us a radius that's, a minimum distance away from the edge of the image that's at least 2 times the average radius. And then we're just going to append this center that we just drew into our list, centers.append center. And we can just take a look what that first entry looks like. So centers 0, 196, 161. So now why don't we just take a look at what the first row value from the first entry looks like. So we know that the first entry into our list is 196, 161. What if I just want this 196, just the row value? That would be our y value, if you will. So we just put a second 0 after it. So we're calling the first list item and then the first item of the first list item, so that 196. So now we want to find the length of our centers list and the length of our radius list, just to make sure that these two numbers are the same. So how do we do that again? Just len centers, that's 20. Let me just put a new cell in here, len radii, 20. And we know that we have an equal number of centers and radii. So what I'd like you to do really quick, just run this block of code. We're resetting our image again and our rows and columns where we were declaring the circles. And this is a longer practical. This is your big practical for this section. You're going to write a for loop for the length of radii or centers list. So you're going to be using our length value. Generate an image matrix with the center positions and the radii pulled from the respective lists. So you don't have to write any new code to generate your radii or your centers. You should already have that, but you do need to draw them where the radii and the centers are. And my question is, should you clear the IMG row column between operations? Just think back to what we said earlier. When we cleared that, what happened? If we left it in place, what happened? And that will sort of make your judgment for you. At the end, to show, I'll just set this code in here for you now, so you don't have to set this, so you can look at your image. So just give that a shot right now and spend 5-10 minutes on it. See if you can make it work, and then we'll finish up by saving the image, and that'll be that. All right, so for our last practical, it was actually just about 3 lines of code, but it probably took you a little while to figure out. That's completely fine. It took me a little while to figure out how to teach it. So we're just going to go for k in range length centers. So we know that our we were doing this earlier by just saying 20, 20 every time, but this is so that if we do change the length of our radii or centers arrays, we have the loop will change with it rather. So now that's just going to hopefully be our 20, and cc equals circle centers. So remember our circle, the first thing it took was our row, our column, our radius, and then image.shape. So first we put in our row centers, k, because that's what we're iterating over, 0, because that's our row value, centers, k, because again, that's what we're iterating over, 1, because that's the column value, and then radii, k, that's the kth radii in that radii list, and then just image.shape. And then we're going to write that into our matrix, image, cc, over all layers is just going to be 1, 1, 1. So the red, the green, and the blue layers are all going to be 1, which would give us, of course, white. And let's just see if this looks okay. And you should get an image that looks a bit like that. Well, how do we save it? We're just going to use plot.imsave, which will just save the plot. If I can cut and paste over here. And that'll save into a different folder depending on your computer. It should save into the working directory wherever you have this file saved. And I'd like to just call your attention here for more tutorials on shapes. This is where I pull a lot of this from. Just plot shapes from Sci-kit image. And it's a really good place to look into it.